Hi everyone, welcome back to my YouTube channel. My name is Hima Shankar, studying in Sri Venkateswara College of Engineering in the Department of Computer Science and Engineering. I am pursuing third semester. Subject is mathematics, and the topic is research point of application in exponential distribution. Contents of today's slides are: what is exponential distribution, formula, mean and variance, memoryless property, sum of two independent exponential random variables, exponential distribution graph, and applications. What is exponential distribution? In probability theory and statistics, the exponential distribution is a continuous probability distribution that often concerns the amount of time until some specific event happens. It is a process in which events happen continuously and independently at a constant average rate. The exponential distribution has the key property of being memoryless. The exponential random variables can be either more small values or fewer large variables. For example, the amount of money spent by the customer on one trip of the supermarket follows an exponential distribution. So the next topic is exponential distribution formula. The probability density of an exponential distribution is f of x lambda, where lambda to the power of minus e power minus lambda x is greater than or equal to 0. Here, lambda is greater than 0 is the parameter of the distribution, often called as rate parameter. The distribution is supported on the interval of 0 to infinity. If random variable x as this distribution, we write exponential of lambda. The exponential lambda distribution exhibit infinite divisibility. Mean, variance, movement of median. The mean or expected value of an exponential distribution random variable x with parameter lambda is given by e to the power of x, e of x is equal to 1 by lambda. The light of the example given below, this makes a sense. A person who receives an average 2 telephone calls per hour can be expected that the time between consecutive calls will be 0.5 hour or 30 minutes. The variance of the x is given by variance of x is equal to 1 by lambda square. So the standard deviation is equal to them. The median of x is given by m of x is equal to natural logarithm 2 by lambda is less than e power x, where it refers to the natural logarithm. Thus, the absolute difference between the mean and median is e power x minus m of x. 1 minus natural logarithm 2 by lambda is less than 1 by lambda is equal to sigma of x, in accordance with the mean, median, and inequality. Memoryless property of exponential. The memoryless property of exponential can be expressed mathematically by exponential distribution by definition by memoryless random variable property course. The exponential distribution has a memoryless property which future probability do not depend on any past. For example, if you are waiting for a customer to enter a store, the memoryless property means that the distribution of waiting time until the next customer is same regardless how long you have already waited. Exponential distribution graph. The exponential distribution graph is a graph of probability density function which shows the distribution of distance or the time taken between events. The two terms used for exponential distribution graphs are lambda and x. Here lambda represents the events per unit time and x represents the time. The following graph shows lambda is equal to 1 and lambda is equal to 2. Exponential distribution applications. One of the widely used continuous distribution is the exponential distribution. It helps to determine the time between the events. It is used in a range of applications such as reliability theory, queuing theory, physics, and so on. Some of the fields that are modeled by exponential distribution are follows. Exponential distribution helps to find distance between mutations of DNA strands, calculating the time until the radioactive particle decays. So you know that the radioactive particles decays in very microseconds, and its half-time period is calculated using the exponential distribution. So the half-life period can be told as the when it decays half, and it is already half done and it has only half left. So the half life period is calculated using exponential distribution, because when we know the half value, we will come to know the full value of the decaying process. Help on finds of the height of different molecules in gas at a stable temperature and pressure in a uniform gravitational field. Helps to compute the monthly and annual highest values of regular rainfall, river outflow, and volumes. So it also helps to calculate monthly rainfall and many other things. Exponential distribution helps to find the distance between mutants on DNA strand. So you already know there are many mutants that on many things on the DNA strand, that is A, T, G, C, anything. So when they get mutated, they may change itself, and the whole property of the DNA changes. So the time gap between getting mutated is nothing but changing. So time gap is covered can be covered or disclosed or can be known by using this exponential distribution application in this process. Thank you everyone for